Hi, my name is Teresa Guerra-Ramos. It is my pleasure to present today the contribution called Vermicomposting in Mexican Secondary Biology Classrooms, Effects on Learning Outcomes and Students' Motivation. In this work collaborate Rocío Valderas Robledo, Jay Renteria Guzmán, and me, who work at Simvestab Unidad Monterrey, and also José García Horta, who works at the Universidad Autónoma de Nuevo León. Both institutions are located in northern Mexico. The problem of how to provide formative and significant science education to young learners in coherence with a wide and demanding curriculum is still a great challenge to teachers around the world. In Mexico, science education has been reformulated in official documents and textbooks with the framework of several curriculum reforms. The state aim of the official curriculum is to provide a background that promotes the development of scientific competences in which knowledge, process skills, and attitudes are integrated. Despite the well-intentioned educational discourse, there is still a lack of resources and concrete strategies that support teaching practice. We report here a study to evaluate a project developed to consistently incorporate activities with living beings as situated teaching learning scenarios. The project is centered in a series of activities related to the transformation of organic waste in a vermicomposting system or composting bin with earthworms. The idea to develop a project of this nature arose from the fact that biology curriculum contents are usually taught without making reference to a concrete living being and without the systematic incorporation of practical activities. Consequently, the aim of this study is to evaluate the learning effects of a long-term project centered on experiences related to composting in secondary biology classrooms. To be introduced to students and teachers, the project was called Worms to School. This science school project entails a situated perspective of teaching and learning, in which knowledge is not independent of the context in which it is used. This perspective arose in the 1980s in contraposition to the then dominant view, which considered that knowing occurred essentially in solitary. Thinking was considered to be detached from the perception and action, and the context was secondary, if relevant at all. The situated knowledge perspective flourished initially in the study of mathematical knowledge applied in real-life settings and in the investigation of teaching and learning of vocabulary and reading skills. Composting bins and earthworms have been used with educational aims in different educational settings with diverse objectives and approaches. Such experiences seem to have an enormous potential to provide concrete context that promotes the intellectual involvement of students and teachers. They have been used to promote argumentation on biological processes and the environmental benefits of composting in reducing organic waste and the reintegration of nutrients to soil. Although vermicomposting systems, commonly called worm bins, have been used for educational purposes for decades, there is still little evidence of their effects in teaching and learning of related biology curriculum contents. Despite their ease of maintenance and affordability, such systems that allow keeping a living being in the science classroom remain marginal as valuable teaching resources in Mexican science education. This mixed methods investigation was intended as an initial study with an intentional sample. 5 teachers assigned to 10 groups consisting of 333 students aged 12-11 were invited to participate. Their participation in a long-term composting project occurred in the context of the subject Science 1, which has an emphasis in biology. Teachers were experienced biology teachers, 3 females and 2 males, working in public secondary schools located in an urban marginal area of Apodaca, Nuevo León, Mexico. Several small groups of students within each class took care of a composting bin with earthworms during a school year. This task involved feeding and dampening earthworms in the composting bin, as well as measuring and recording temperature and humidity regularly. Teachers and students engage in activities related to nutrition, respiration, reproduction of earthworms and their role in the environmental processes. Students' productions were collected in selected sessions. At the beginning and the end of the project, students responded to a questionnaire that explored biological knowledge, some process skills, and environmental awareness attitudes. Students also produced free text about what they like and dislike in the project. Students and teachers participate in 2 types of activities. Collaborative open-ended activities. Students working in small groups and coached by teachers were responsible of handling a composting bin with earthworms during a school year. That's 10 calendar months. This involved finding out the right type and amount of food and water to maintain alive the earthworms in the composting bin. Additionally, students had to use a hydrothermometer in order to measure and record temperature and humidity once a week. Students could decide the best ways to make decisions, organize duties, and solve problems. In structured classroom activities, teachers and students engage in a series of activities to learn about biological characteristics of earthworms, aspects of their nutrition, respiration, reproduction, and their role in the biological processes related to transformation of organic waste into nutrient-rich soil called compost. These activities were conducted in a monthly session lasting 80 minutes approximately. Our main sources of data to estimate the educational effects of the project were students' responses to a questionnaire exploring biological knowledge about earthworms-related process skills like understanding, interpretation, and application of information, and environmental awareness attitudes. This is towards generation of garbage and living beings. This questionnaire was applied at the beginning and at the end of the project. We also had students' records of temperature and humidity and the students' productions in selected classroom activities like drawings, charts, figures, etc. For the purposes of this presentation, we concentrate in the questionnaire results. Data collection was completed at the end of the school year, in July 2015. In the whole sample, the mean of initial score, that is the percentage of right answers, was 45.8, and the mean of the final scores was 63. This table shows means of initial and final scores for each of the 10 groups, each school, and the whole sample. In all cases, the final score increased and the difference among initial and final scores had statistical significance. The increase among initial and final scores ranged from 9.4% to 24.5%. Group 10 obtained the lowest increase and Group 4 got the highest increase. Now let's have a look at the results obtained in terms of increasing the percentage of right answers in each section of the questionnaire. The data suggests that the students improve significantly in their biological knowledge about earthworms and composting, their ability to understand, interpret, and apply related information. According with data from questionnaire, attitudes toward generation of garbage and living beings also increased, although not significantly, since attitudes were good in this respect from the beginning. Students' records of temperature and humidity suggest that at the beginning of the project, students did not use confidently the hydrothermometer, confused data, and made irregular and mechanical records without interpretation. These tendencies start changing by the 5th month. By the end of the project, students tended to make regular weekly records, write down interpretations that were more accurate, so to speak. 11 out of 54 student small groups did not manage to keep regular records or relay data to find out the best conditions in terms of temperature and humidity for earthworms. Students' productions in classroom activities indicate an overall tendency of a progressive gain in the use of data to elaborate and use graphs of temperature and humidity. We also identified texts elaborated by students in which initial feelings of repulsion towards earthworms were gradually left behind. Students also expressed a sense of responsibility connected to the experience of keeping earthworms alive and working collaboratively in small groups. Teaching biology at secondary school should include significant context and engaging situated activities. It is ironic that the learning about living beings frequently occurs in the Mexican context without the opportunity to experience activities with living creatures. Our evaluation of the learning effects of the project is serving us as a starting point for further research, development, and improvement of teaching resources for secondary science education. Although most of the results indicate positive effects on learning biology concepts, process skills, and attitude contents, we recognize that the uptake of innovation strategies is not simple or straightforward. Activities with living beings in the secondary science classroom imply temporal and material limitations, as well as convincing teachers, students, and other educational actors, like head teachers and parents, to be engaged in an effort to avoid mechanical and decontextualized science teaching and learning. In future research work, we aim to refine our methodology to focus on the development of scientific thinking skills and the potential of long-term projects as a means to reinforce teacher professional development. Many thanks for attending this presentation. Here we leave the contact emails of me and my colleagues. Thank you very much again and enjoy the rest of the conference.